Hey everyone, in this video here I'm going to show you a little bit of a shortcut that we can sometimes use when dealing with anti-differentiation by parts. It's called tabular integration. Really the key here is we have to recognize when is this going to be used, and the kind of the giveaway is that we need whatever term that we would plug in for u, which in this case would clearly be x cubed. The reason I would make x cubed equal to u is that it's easy to take the derivative of that, and I know that eventually, if I keep taking that derivative, it eventually goes to 0. It would be 3x squared, 6x, then 6, then 0. And I know that dv is going to be this sine x dx, where it's easy to take the antiderivative of that. So again, tabular integration is going to be used when I can take multiple derivatives here very easily and multiple antiderivatives here also very, very easily. So what we're going to do is I'm going to list out, I'm going to call this right here, call that u. So u is equal to x cubed, and we'll call, I guess, v equal to sine x dx, or if you want to call that dv, sort of keep that thing going, that's a good idea. But what I'm going to do is I'm just going to make a table, and in this table I'm going to have u and all its derivatives and v and all its antiderivatives. So let's just go ahead and make these two columns. So this is going to be u and derivatives. And this here is going to be dv and antiderivatives. Okay, so we start here, and the first one we're going to have obviously is x cubed, and then the derivative of that is going to be 3x squared, and the derivative of that is going to be 6x. The derivative of that is going to be 6, and then the derivative of that obviously would just go down all the way to 0. That's kind of how I know where I'm finished. Okay. For dv and the antiderivatives, the first one we have here is sine x. The antiderivative of sine x is going to be the negative cosine x. The antiderivative of the negative cosine is going to be the negative sine of x. And then the antiderivative of the negative sine of x is going to be the cosine of x. And then the antiderivative of the cosine of x is the sine x. Okay? And so what I have now is I have these list of terms that I'm going to be able to use. What we have to kind of figure out is sort of which ones to use with what. And so it's always going to be the derivative, or the u and its derivative versus the next one down in the column over here. So the x cubed is going to go with the negative cosine x. The 3x squared is going to go with the negative sine x. 6x is going to go with the positive cosine x. 6 is going to go with the sine x. The one thing we have to make sure that we do is pay attention to the signs. So it's always a positive sign, negative sign, positive sign, negative sign. Okay, so what that means in terms of writing out our final answer, okay, is that this is going to be a positive x cubed, but we have a negative cosine x. So I have a positive and a negative. That's actually going to come out to be negative. So we're going to get negative x cubed cosine x. Okay, and we look at this next one here. We have a negative and a negative. That makes this going to be a positive term now. Okay, so we're going to end up with plus 3x squared sine x. And we look at our next one here. And again, we have 6x and a positive cosine x. It's a positive term, so it's just going to stay positive. So plus 6x cosine x. And then we have a 6 and a sine x, and this one is supposed to be a negative term. So this whole thing comes out to be negative minus 6 sine x. And then we need our constant of integration at the end, that plus c. So this whole thing here ends up being our final answer. Okay. So I hope this video helps. Again, it's a nice little shortcut. But again, the part that you have to make sure of is that this x cubed or whatever you have for u is going to eventually differentiate all the way down to 0. It might take 4, 5, 6 derivatives to get there, but eventually, those derivatives are going to 0, and whatever you choose for dv is going to be very easy to continually anti-differentiate. All right, so I hope this helps, and I'll see you in the next one.